Hello class, welcome to our video project on Isaac Newton's laws of motion.
Mr. Newton gave us 3 laws with which all motion on our planet pretty much follows.
Isaac Newton was born on December 25th, 1642. His book, Mathematical Principles of Natural Philosophy, also known as the Principia, is a collection of 3 books, first published on July 5th, 1687.
In this book, Newton stated the 3 universal laws of motion. These same laws enabled many of the advances of the Industrial Revolution, and today these same principles apply in our everyday life.
Newton's first law, also known as the law of inertia, states that an object at rest tends to stay at rest, and that an object in uniform motion tends to stay in uniform motion unless there's a net external force.
In our video today,
we're gonna get down with these 3 laws.
Move, ball! Move! Just move, ball! Will you move? Move! Move!
what are you doing?
What are you talking about? I'm trying to get this ball to move.
Did you know that the first law also states that an object at rest will stay at rest unless there's an unbalanced force acted upon it?
So I've been yelling at this ball for an hour for no reason?
Yeah, pretty much.
Great. There's laws of motion. The first law states that an object in motion will stay in motion unless there's an unbalanced force. Newton's laws, baby.
Let's see exactly what happened here. Newton tells us an object at rest will remain at rest unless acted on by an unbalanced force. So, Conor has the football in his hand, an object at rest. He uses force by the action of throwing. When he uses the force to throw, the object, or football in this case, begins its motion towards me.
The second part of this law is, an object in motion continues in motion with the same speed and in the same direction unless acted upon by an unbalanced force. Now that the football I've thrown is in motion, we have several forces working against it to decrease its speed and direction. First, we have gravity. Gravity is constantly pulling the ball downward. Secondly, we have air resistance. The atmosphere itself has small particles working against the motion of the ball in the form of friction, slowing it down. And thirdly, we have Josh catching the ball, basically stopping the motion of the thrown ball. And there you have it, Newton's first law.
Hey Connor, I bet you can't kick that house further than I can kick this ball.
Oh yeah? That was nothing. My turn. Oh! Son of a Isaac Newton!
In this video, me and my little brother Logan are demonstrating the second law of motion. As you can see, Logan is using his mass and the acceleration of his leg to generate force into the ball, causing it to elevate into the air.
In the second part of this demonstration, Conor tries to kick the house as far as his brother tried to kick the ball. But what Conor doesn't know is that he doesn't have enough mass or acceleration to even move the house. I'm going to go for my afternoon jog. What the? I wonder who threw that. When I went for my jog today, a random pedestrian hit me with a yoga ball, not knowing he would demonstrate the third law of motion.
The third law states that for every action, there is an opposite and equal reaction, which is demonstrated in this video by Josh getting hit by the ball, by that random pedestrian. There you have it, all 3 laws. To sum it up, An object that is in motion will stay in motion, and an object that is in rest will stay at rest unless acted on by a net external force. Force equals mass times acceleration. For every action there is an opposite and equal reaction.
We had another example of Newton's laws in effect. Unfortunately, Mr. Newton's laws got the better of old Connor here. Have you noticed the sling on Connor's arm? Well, Connor was giving it all up for Mr. Newton and his laws in a daredevil attempt to present on this video measure of forces at work.
Yes, I took the dummy pill that week, got on an ATV, and crashed and burned. The outcome, well, you're looking at it. While jumping over Rock Canyon, you can see in this first simulation, laws 2 and 1 are in that order working. Look at me go, high as a kite.
Well, as we discussed, Connor also felt the negative effects of Newton's first law, namely, an object in motion will stay in motion unless acted on by an external force. What kind of force? You guessed it, gravity.
Well, down I go, thanks to gravity, as I hit rock bottom, literally. Newton's third law hit me hard, again literally. As I hit the ground with tremendous force, my collarbone absorbed as much of the force as possible, and then broke.
How's that for giving it up for science?
We hope you enjoyed our little video on Sir Isaac Newton's laws of motion. Be safe!